Solving logarithmic equations. Solve the following logarithmic equation. Be sure to reject any value of x that is not in the domain of the original expression. Give the exact answer. First, we're going to rewrite this logarithmic expression in exponential form so we can solve for x. So I have a base of 6, an exponent of 2, and that equals x plus 6. Next, we'll simplify 6 squared, that's 36, so 36 equals x plus 6. Next, subtract 6 from both sides, and we get 30 equals x, or x equals 30. If we plug this value back into the original problem, you'll see I'll get log base 6 of 36. Now I can take the log of 36 since that value is greater than 0. So I know that x equals 30 is in the domain of my original expression. So x equals 30 is my answer. Solve the logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. Give the exact answer. Here I have log base 6 of x plus 26 minus log base 6 of x minus 9 equals 2. If you'll notice on the left side, I have two log expressions and they have the same base. When that happens, I can combine those into one logarithmic expression. Since these are being subtracted, I'm going to use the quotient rule. That tells me to take the log of base 6, and then the first expression is going to be my numerator, and that's going to be divided by my second expression, which is my denominator, and that equals 2. Next, since I have a single logarithmic expression on my left and an answer on my right, I can rewrite this in exponential form. My base is 6, my exponent is 2, and that equals x plus 26 over x minus 9. Now I'm just going to solve for x. To do that, first we'll simplify 6 squared, that equals 36. Next, we're going to multiply both sides by the denominator to get rid of the x minus 9 in the denominator position. So when I do that, I get x minus 9 times 36 equals x plus 26. Now I'm going to distribute the 36 to both terms within parentheses. I get 36x minus 36 times 9, which is 324, and that equals x plus 26. Now we'll move all the numbers on the right side and all the x's on the left side. So I'll subtract x from both sides, and we get 35x minus 324 equals 26. Now we'll add 324 to both sides, and I'm left with 35x equals 350. Lastly, we'll divide by 35 on both sides, and I get x equals 10. And again, we can take this value and plug it in for x in my original problem, and you want to make sure that the log, the number within the log, is greater than 0. If it is greater than 0, then I know I can take the log of it and I'll have a real solution. And x equals 10 does check out, so I know that that's my answer.